If you're new here, my name is Mike. I'm a cloud security engineer, and this channel is how I break down cloud, cybersecurity, AI, and modern tech careers in a way that actually makes sense. Today, I want to talk about something that quietly determines whether people succeed or fail in security interviews. A lot of people think they're getting rejected because they don't know enough tools, and they think maybe I need another cert, or maybe I need to learn another SIM, maybe I need to memorize more AWS services. But that's actually not the real issue. Most engineers struggle because their security fundamentals aren't strong enough yet. Hiring managers don't reject you because you don't know Terraform or Vault. They end up rejecting you because you can't reason about risk, architecture, or how attackers actually move through systems. And in 2026, that problem is even bigger because now we're securing AI systems, cloud infrastructure, APIs, and distributed workloads all at once. So in this video, I want to walk through something simple: the 3 layers of security engineering knowledge: junior, mid-level, and senior. And I'll show you where AI security fits into all of this because that's becoming a huge part of modern systems. Let's start with the foundation. The first layer is what I call the junior security engineer foundation. And this is where you're basically learning how systems actually work before you try to secure them. The first major area here is networking and OS, operating systems. And you need to understand things like how TCP/IP works, how HTTP requests move through the internet, how ports and services expose apps, how Linux manages users, processes, and permissions. Because attackers don't break tools, they break systems. For example, a common early attack technique is simple service enumeration. An attacker might run a scan using a tool like Nmap to see what ports are open. And maybe they discover SSH on port 22, a web server on port 443, or a database accidentally exposed on port 3306. That information alone tells them where to start. So if you want to learn this hands-on, platforms like TryHackMe, HackTheBox, FortSwigger, Web Security Academy are excellent. And you can also spin up small labs locally using Docker or vulnerable apps like OWASP Juice Shop. Watching how attacks actually work will teach you far more than reading about them. And the next concept at this level is core security principles. So you'll hear about the CIA triad a lot, which is just confidentiality, integrity, and availability. But the most important part is how those show up in real world systems. So if attackers steal your customer data, confidentiality is broken. If someone manipulates financial records or machine learning outputs, integrity is compromised. If attackers take down an API or service, availability is gone. And another huge principle here is least privilege. Users should only have the permissions they absolutely need. So in cloud environments, this is very critical. Many breaches happen because an app or an identity had excessive permissions. For example, a compromised cloud workload may have an IAM role that allows full access to storage buckets or databases. That's how small compromises turn into massive breaches, basically. Another core skill is authenticating systems. So that's things like OAuth, JWT tokens, session cookies, SSO, and these are just the mechanisms controlling identity across modern apps. If authentication is weak, attackers don't need to hack the system. They simply just log in as somebody else. A common example is session hijacking or token theft, which tools like Burp Suite can demonstrate when testing web apps. Now, once engineers move beyond that foundation, they begin thinking more like mid-level security engineers. At this stage, you're no longer just looking at individual machines. You're thinking about entire systems and architectures. One of the most important skills here is threat modeling. Threat modeling simply means asking, if I were an attacker, how would I break into this system? And you might draw a diagram showing a web app, an API layer, a database, a cloud storage service, an AI model endpoint, and then you start identifying trust boundaries and attack surfaces. Frameworks like Stride help categorize attacks. For example, an exposed API might allow enumeration of user data. That data could reveal internal identifiers, and those identifiers might allow privilege escalation through another service. This kind of chained attack is extremely common. Mid-level engineers also need to understand cloud security architecture. Most modern companies run infrastructure on platforms like Oracle, AWS, Azure, GCP, and today many attacks in cloud environments involve identity misuse rather than server exploits. For example, attackers might steal a credential from a compromised container. Then they use that credential to access cloud APIs and enumerate resources. Remember, if permissions are too broad, they can access storage buckets, secrets, or even deploy malicious infrastructure. This is why strong IAM design, secret management, and workload identity are critical. Technologies like AWS IAM roles, Azure Entra ID, Workload Identity Federation are used to reduce the risk of static credentials. Now, here's where things get really modern. Security engineers today are also responsible for AI system security. Many companies are deploying AI systems using services like OpenAI APIs, Anthropic models, AWS Bedrock, Azure OpenAI, self-hosted open source models. These systems introduce new attack surfaces. One major risk is prompt injection, and this is when an attacker manipulates the input given to an AI model so it performs unintended actions. Another risk is data leakage through model responses. If an AI system is connected to an internal business document or database, a malicious prompt potentially extracts sensitive information. This is why engineers now design guardrails around AI systems, including input input filtering, output validation, access control, logging and monitoring. AI security is quickly becoming part of mainstream application security. Mid-level engineers also focus on security in CI/CD pipelines. Because modern infrastructure is deployed automatically, security checks must also be run automatically. So teams often add tools like Trivy for containers, vulnerability scanning, SimGrep for code analysis, GitLeaks to detect exposed secrets. The goal is to catch issues before they reach production. Another major responsibility at this stage is incident response. When suspicious activity is detected, engineers must investigate quickly. So security teams analyze logs, isolate compromised systems, and determine how attackers move through the environment. Frameworks like MITRE ATT&CK help classify attacker techniques like credential dumping, lateral movement, privilege escalation. Understanding these patterns help defenders respond faster. Finally, let's talk about the senior security engineer level. And at this level, the focus shifts from finding vulnerabilities to designing secure systems at scale. Senior engineers spend much more time thinking about architecture. Things like how identity should be structured across the company, how secrets are stored and rotated, how logging and monitoring systems are built, how AI systems access internal data. They design security guardrails that apply across the entire platform, not just individual applications. Senior engineers also align security controls with frameworks like NIST, ISO 27001, or SOC 2. But the real deal is translating those frameworks into practical engineering decisions. They also lead major incident investigations. When a breach or a major security event happens, senior engineers coordinate response, analyze attacker behavior, and help teams strengthen defense. And another huge part of the role is mentorship, helping developers understand security earlier in the design process, building systems that are secure by default instead of patched later. So if you're trying to break into security right now, here's the honest advice. Don't rush straight into tools. Spend time understanding how networks work, how identity systems work, how cloud permissions work, how attackers move through systems, and increasingly how AI systems interact with data and APIs. Use platforms like TryHackMe, Hack the Box, or build small labs in AWS or Azure. Deploy a small application, add authentication, add your database, maybe even connect it to an AI API, and then just try to break it yourself. You want to fix the problems. And that process will teach you more than any certification ever will, because tools change every year, but security fundamentals and how attackers think stay the same. And the engineers who understand those fundamentals are the ones who eventually design the systems.